My name is Michael Vetter, and I work at Lawrence Berkeley National Laboratory in the Building Technology and Urban Systems Department. And there I lead a team that develops new generation computing tools for building and community energy grids. So Lawrence Berkeley National Laboratory is one of the US Department of Energy research lab. And we do unclassified research across a variety of disciplines, so ranging from energy applications to mathematics, physics, computer science, and there are about 4,000 researchers at Lawrence Berkeley National Lab. Some of them have joint appointment with UC Berkeley, and we also produced numbers of Nobel Prizes. So open standards like Modelica and FMI are important because you basically don't depend on one particular vendor at the end. So you really get an open ecosystems where you have different disciplines working together, which we see one of the main benefits, because through that you get the domain expert who develop libraries, you get the mathematicians who develop solvers, and then also the tool developer who provide computer tools for simulation and for modeling, and then the whole service and consulting for these particular tools. So I think the main benefit is really it's an ecosystem of different researchers and developers that work on a common platform, and through this standard you enable such a platform to actually exist. Yeah, I think the benefits of using Modelica are really that it enables you to do rapid prototyping. Because what's meant by that is often you may envision a new product or new system configuration, and in standard simulation tool it typically takes months, sometimes even a year to implement a new system, because you depend on the actual tool developer to do all the implementation. And with Modelica, a researcher can quickly extend existing tools, reconfigure them, or existing models, reconfigure them, and then analyze new systems that have not been implemented yet by the tool developers. FMI as a standard is useful because a lot of companies may want to use their existing simulator, whether it's because they have training in them, or they have libraries in them, or they may use special purpose solvers. And FMI provides now a standardized interface that allows you to couple this existing simulator with models from Modelica or with models from other simulators to do an integrated analysis or to embed such models directly into building automation systems. I started looking at Modelica around 2002 and was quite surprised about the formal definition of such a rich modeling language. And in 2004, I started using it in projects to design building energy system. And I saw primarily the value there because it allows me to use it as a platform to bring my building domain expertise into a project and use in the same language also to interact with other domain experts from controls and from system engineering, and use it really as a platform for interdisciplinary research. So Modelica served me well because it's really an open platform, and it allows you to do open source development, and there's a large community that you can interact with. And that led to the Buildings library, which is now used worldwide by equipment manufacturers and also by practicing engineers and by academia. And just recently we started an international project under the umbrella of the International Energy Agency that further develops Modelica and FMI technology, and we have now 35 institutes from 17 countries participating in this multinational collaboration to bring computing tools for building to the next state of technology.